Hello everyone, I'm Teacher Al. Welcome to my channel. Okay, today we're going to study distance problem for grade 7. Okay, we have now number 3 problem. Mr. Rivera headed south driving his car 60 kilometers per hour. After 30 minutes, his son followed driving another car at a rate of 70 kilometers per hour. How long will it take Mr. Rivera's son to overtake him? So this problem asking for the time to overtake Mr. Rivera's sons. Okay, our solution, we have to pick up first the given. The given Mr. Rivera rate is 60 kilometers per hour plus 1/2 hours. Then sun rate is 70 kilometers per hour. Our representation, let x be the time traveled of the sun, and then x plus 1/2 be the time traveled of Mr. Rivera. And our equation, distance traveled of Mr. Rivera is equals to distance traveled of the sun. To solve the equation, since we have the distance is equals to RT, and equals to RT. Then we have to substitute the rate of the Mr. Rivera is 60, and the time covered by Mr. Rivera is x plus 1/2 equals the rate of the sun is 70 times x. We use x because the time travel of the sun is x. Okay, then next is we're going to simplify. I will use the distributive property. 60 times x equals 60x. 60 times 1 equals 60 divided by 2 equals 30 equals 70x. And then we have to transpose all the variable to the left side of the equation and the constant to the right side of the equation. Okay, 6x, then 70x transposed to the left side of the equation becomes negative 70x equals the positive 30 becomes now negative 30, because when we transpose we're going to change the sign. And now next is to simplify. 6x minus 70x equals negative 10x equals negative 30. Okay, we're going to divide both sides by negative 10, and our x now is negative 10x divided by negative 10 equals x equals negative 30 divided by negative 10 equals 3. So therefore, the time travel covered by the sun is 3 hours. Our complete answer, 3 hours times of sun to overtake Mr. Rivera. Okay, we have another problem. Carla is driving 50 kilometers per hour. How far will she travel in 4 hours? Letter A. B was 6.5 hours, and C 20 minutes, and D Y minutes. So the problem now asking what is the travel time? What is the distance covered? If for letter A, the hours is 4 hours. Okay, we will use our solution. We will use D equals RT for letter A. Then the given the rate is 50 kilometers per hour. Then we are going to multiply by time, which is 4 hours covered in letter A. And then 50 times 4, we're going to multiply, becomes 20 kilometers per hour, the distance covered by letter A. For letter B, we have the same formula that we're going to use. D equals RT equals 50 again, the rate kilometers per hour given. Then the time covered is 6.5. Then we're going to we are going to multiply 50, then the 6.5, which is mixed number, we will change this to improper fraction. Then we're going to multiply 50 times 13 divided by 2. So the result is 325 kilometers is the distance for letter B. And for letter C, D equals RT, again our formula. Then the same kilometers per hour, covered is 50, and 20 minutes, it's about to divide by 60 because our rate is and state and hour. That's why we're going to divide it by 60 minutes. So our to simplify now, 50 times 200 divided by 60, we have 1060. Then 1000 divided by 60, we have 16.67 kilometers covered. And letter C. Okay, letter D. Letter D, we have the same formula that we're going to use. D equals RT, then equals the same rate, 50 kilometers. And the time is Y. So our since Y is minutes, so we're going to divide it by 60. So then we're going to multiply 50 times Y divided by 60. So our answer is 50Y over 60. Then we're going to divide it by 10. So that's why our final answer is 50 over 6 Y kilometers. That's for letter D. Okay, we have number 2 problem. Carlo traveled 260 kilometers. What was his rate if he made the trip in 10 hours? For B, 4 hours. And C, Y hour. So in this problem, asking for the rate of travel or the speed of travel by Carlo. So our solution for letter A, we're going to use again the common formula D equals RT. So since the given is the distance 260 kilometers, we're going to substitute for D 260 equals R not yet given, but the time is given to 10 hours. Then we're going to multiply 260 bring down equals R times 10 equals 10 hour. Then we're going to divide both sides by 10, and 10 divided by 10 equals R, and 260 divided by 10 equals 26. So therefore for letter A, the rate is 26 kilometers per hour. For letter B, the same formula that we're going to use, D equals RT. D is 260, the distance, equals, for letter B, the hour covered is only 4 hours. Then we're going to multiply 4 times R equals 4 hour. Then we're going to divide it by 4, both sides. So that's why 4 divided by 4 equals R, and 260 divided by 4 equals 65. So therefore, the rate of letter B, if Carlo traveled for 4 hours, is 65 kilometers per hour. And for letter C, the same formula that we're going to use, D equals RT, and the given distance is 260 equals R times Y. Because for letter C, Y, R is the given. Then 260 equals R times Y equals YR. And we're going to multiply both sides by Y. So that's why our rate for letter C, R equals 260 over Y kilometers per hour. Okay, another problem, number 3. Marlon traveled 360 miles. How long did it take him if his rate was A, 50 miles per hour, 60 miles per hour, and letter C, ZM miles per hour? Okay, in this problem, asking for the time travel of Marlon, which is covered for 360 miles. Okay, that's the distance. Now our solution, the same. We're going to use the formula D equals RT. Since the distance is given, we're going to substitute for D, becomes 360 equals, the rate is also given. For letter A, we have 50 times T. And then, since we're going to compute for the time, we're going to divide both sides by 50. And 50 divided by 50 equals T. And 360 divided by 50 equals 7.2 hours. So therefore, for letter A, the time travel covered by Marlon is 7.2 hours. For letter B, the same formula that we're going to use, D equals RT, and we're going to substitute for D given in the problem is 360 the distance, and the rate is also given for letter B with is 60 and T, and we're going to solve for the time troubled. So we're going to divide both sides by 60. 60 divided by 60 equals t, and 360 equals 60 equals 6 hours. So therefore the time troubled for Marlon and letter B is 6 hours. For letter C, D equals RT, and the distance given, so we're going to substitute 360 equals ZZ. Then 360, we're going to divide it by both sides by Z, and Z divided by Z equals T. And now our time is 360 divided by Z hours. So therefore, the time travel covered by Marlon in letter Z, in letter C rather, T is equals 360 over Z hours. Distance problems part 3 grade 7 number 5 problem. At 7:30 a.m. first airplane leaves Manila for Cebu, a distance of 400 miles. The first plane flies at 200 miles per hour. A second airplane leaves Manila at 7:45 a.m. and is scheduled to land in Cebu 15 minutes before the first airplane. At what rate must the second airplane travel to arrive on the schedule? So the problem I'm asking for the rate of the second airplane. So our solution, first airplane, we have to get the time travel. So we will use the formula T equals D over R, and the distance covered of the first airplane is 400, and miles per hour, or the rate, is 200. Then we're going to divide it, 400 divided by 200, 2 hours. Okay, 2 hours the time travel of the first airplane. Then we have to compute the arrival in Cebu. At 7:30 a.m., then plus 2 hours, so we have 9:30 a.m. the time of arrival in Cebu of the first airplane. Then the second airplane we're going to compute again. The first airplane arrival in Cebu 9:30. Then we have to minus the 15 minutes ahead of time of the second airplane Then the time of arrival in Cebu of the second airplane must be 9 hours and 15 minutes in the morning. So the time travel of 9:15, we're going to subtract. It becomes now 9:15 becomes 8 and 75. Then we are going to minus the 8 hours and 45 minutes. So 8 and 75 minus 8 and 45, so we have 30 minutes the time of travel of the second airplane. Our next step is to find the rate of the second airplane, which is required in the given problem. So the rate is equals to D over T, that's our formula. So the distance covered is 400 over 30 over 60. Why 30 over 60? Because a time covered is 30 minutes. We have to divide this by 60 minutes because our rate is expressed in R. That's why we're going to divide the 30 minutes into 60 minutes. So 400 over 1 times 60 over 30. Then by cancellation method, we have 60 divided by 2 equals 2, 30 divided by 1 equals 30 divided by 30 equals 1. Then horizontal multiplication, 400 times 2 equals 800 miles per hour. Our complete answer, 800 miles per hour, the rate of second airplane just to arrive on schedule. Okay, next problem, number 6. An express train traveled 60 kilometers per hour from Pasay to Monumento. A local train traveling at 40 kilometers per hour takes 2 hours longer for the same trip. How far apart are Pasay and Monumento? So asking for the distance. So our solution, express train, we will use the distance equals RT formula. Then the local train also distance equals RT. Then the rate of express train is 60 and the time covered is 2 hours. So it becomes distance of the express train is 120 kilometers. The local train, we have the rate is 40 times 2, we have the distance covered is 80 kilometers. So our equation is distance equals the express train plus the local train. Distance equals distance of the express train first, and the second distance is the local train. So the distance covered by the express train is 120 kilometers, and for the local train is 80 kilometers. We have to do is to add. So the distance covered from Pasay to Monumento is 200 kilometers. So therefore our complete answer is 200 kilometers is the distance from Pasay to Monumento.